Consider a system of two particles having masses m1 and m2. If the particle of mass m1 is pushed towards the mass center of particles through a distance d, by what distance will the particle of mass m2 move so as to keep the mass center of the particles at the original position? A. m1 by m2 into d, b. d, c. m1 by m2, and d. m1 by m1 plus m2 into d. First of all, let us understand the question by drawing a diagram of it. Here we have two masses m1 and m2, which has a center of mass almost over here, and it is separated by r1, r2 distances. So we are given that m1 is moved towards the center of mass by distance d. So we can draw the final position like this: center of mass m1. So we move the m1 by distance d. We have to find by which distance we move the m2 such that the center of mass stays in the same position. So we have r2 and we have to move by a distance. So let us assume it to be d dash. D dash is what we have to find over here. So let us understand the question. Now we have to write the equations for the both of these figures. We obtain two equations. This is the equation of conservation of linear momentum. The first equation is m1 r1 is equal to m2 r2, and the second equation is m1 into r1 minus d is equal to m2 into r2 minus d dash. Let us subtract the two equations, 1 minus 2, which obtains as m1 r1 minus r1 plus d, which is equal to m2 into r2 minus r2 plus d dash. We can cancel all the r and we get m1 into d is equal to m2 into d dash. D dash is equal to m1 by m2 into d, which gives us A is the answer.